If nothing escapes a black hole, how does gravity escape? Could we detect a faster-than-light spacecraft cruising through the solar system? What does James Webb really orbit at L2? And in Q&A Plus, could the universe have started as a black hole? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are, across my channel. If a question pops in your brain, just write it down. I'll gather them up and I'll answer them here. All right, let's get into the questions. Shahbaz Rezaei, how is it possible that light cannot pass the event horizon, but a black hole has gravity? How do gravitational waves pass through the event horizon if they have the same speed as light? So you're like kind of asking like, how do gravitational waves, like how can a black hole emit gravitational waves? And so gravitational waves are a consequence of moving mass. And so if a black hole moves, then the distortion of its mass in space-time is what is releasing the gravitational waves. And so you kind of can't have mass moving without gravitational waves. Black holes are made of mass, therefore they have gravitational waves. But so like one interesting question is like, what happens if a gravitational wave hits a black hole? Right? Then it wasn't created by the black hole. So now it's sort of crossing into the event horizon of that black hole. And they'll go into the black hole and they will actually be added. So like the energy or the mass equivalent of the energy in the gravitational wave, the exact part of the gravitational wave that hits the black hole event horizon will join the black hole and be added to the mass of the black hole. The gravitational waves that were just missed the event horizon, they'll get caught up in the distortion and they'll be refracted and, their directions will change because of the curved and twisted spacetime as they get really close to the black hole. But you kind of just like can't get gravitational waves without moving mass, and black holes are the most mass moving. Fleshmagi, realistically, how long do you think it will be until we start mining asteroids? 100 years, maybe? Right now we are standing on top of all of the minerals that we require. And for us to attempt to go to another world, an asteroid or whatever, and try to extract minerals from that place is ludicrously expensive. When you think about, say, OSIRIS-REx is a good example. Like OSIRIS-REx mined an asteroid. It was sent from Earth for over $1 billion. It was able to pick up a few, 100 grams from the surface of asteroid Bennu and return it back to Earth. And so what are we paying? $10 million per gram for material from an asteroid, which is really expensive because you could just dig a hole in the ground and find it for cheaper. And so for the longest time, unfortunately, even though there is theoretically a lot of very precious minerals in these asteroids, it's going to be too expensive. And so the classic saying that I always use is that if there was just someone had gone and left blocks of the most expensive minerals that we know of. Like maybe there's blocks of iridium sitting on the surface of an asteroid, and like they're worth hundreds of thousands, millions of dollars per block. It still would be too expensive to send a spacecraft to go and just like pick them up and bring them back home. And so really it's when we start to have some kind of off-planet existence, when we have a research station on the moon, when we have a research station on Mars, where they're going to require resources that, locally to live off the land, is when our space mining will begin. And so then, they're going to be able to dig into the permanently shadowed craters of the south pole of the moon. They're going to be able to pick up water ice. They're going to be able to take the regolith that's all around them and start to turn that into metal and oxygen and various things that they will be able to make use of. But they're not going to need a lot, and they're not going to need, whole asteroids mined. And it really won't be until we have significant infrastructure in space that asteroid mining is going to become some kind of ongoing industry. And we're not there. Like, we're just not there. We are maybe 10 years away from, so maybe we're a couple of years away from NASA setting foot on the moon again. Maybe we're 10 years away from the Chinese doing the same. Maybe we're 20 years away from a permanently inhabited station on the moon. Maybe we are 30 years away from a permanently inhabited station on Mars. And then those need to build up beyond just purely a research station to the point they're going to need resources. And it's never going to make economic sense to bring this stuff back to Earth because, again, we just dig a hole in the ground and the stuff is there. You know, the Earth is made of the same stuff that the asteroids are made of, just more of it and more convenient. So it's really hard to make the case. And so we've seen many companies start up that say they're going to do asteroid mining, and they all go out of business because there's no business model yet that is better than just digging a hole in the ground. So yeah, I mean, who knows what the actual time frame is going to be, but be prepared for it to be a really long time. I won't be alive for it. You probably won't be alive for it. Naked Hand, my son recently asked, what happens if a star collides with a black hole? So the star is torn apart by the intense gravitational forces around the black hole. And astronomers have seen this in action. So they've seen examples out there where you have a black hole and the black hole has a star that is orbiting around it. And every time the star gets too close to the black hole, it gets torn apart a little bit, and then it releases a lot of energy, and then the star continues on this journey around the black hole and then comes back through the accretion disk or comes back close to the black hole, gets torn apart a little bit more, and the black hole just continues to snack on the star until eventually it has eaten all of the mass of that star and the star is gone and it's added to the mass of the black hole. Ashley O'Brien, was there a time in the early universe when the conditions were like standard temperature and pressure? So standard temperature and pressure, as I understand it, this is like Earth conditions. So habitable conditions, air pressure, and so on. And so the early universe, like when you think about it, when the cosmic microwave background radiation was released 380,000 years after the Big Bang, the temperature of the entire universe was about 3,000 degrees. And then it kept cooling down. And by about the 12 million year mark, the universe entered the habitable zone. In other words, the entire universe was below 100 degrees. And I forget, it's about 12 million years. I forget the exact number, but it's roughly that, like say within a few tens of millions of years after the Big Bang. And then it cooled down over the course of several million more years. So for millions of years, until it reached zero. And then I guess things froze, and then it can continue going all the way down to its current temperature. It was like 2.7 Kelvin. And so there was a time when every part of the entire universe was in the habitable zone. But I don't know about the pressure. Like when the universe was the size of the cosmic microwave background radiation, it was a billionth of its current size. But a billionth of the universe's current density doesn't get you to air pressure. So I don't know exactly what the density was at that point. But it's kind of interesting to think that the entire universe. So the question is like, what's habitable? So could there have been life back then? And the problem was that there weren't enough metals yet. So all you got from the Big Bang was hydrogen, helium, lithium, a little bit of beryllium. And the first stars hadn't even really formed. And it's in the stars that you would need to get the nucleosynthesis to create the heavier elements, and the heavier elements like carbon and so on, that could create life. But there's a couple of papers that talk about this time when the universe was entirely habitable, and they propose ways that maybe, if there were black holes that had formed directly and that there were accretion disks in those black holes, so you get nucleosynthesis in the accretion disks of black holes. And so maybe that could have been a source of heavier elements that could have seeded the early universe and started life earlier than we ever thought. Typically people think, well, the universe wasn't really habitable until about 2 billion years after the Big Bang, but the universe ends up being weirder and stranger than we think. So who knows? It's time to shout out all the new patrons at the $5 level and above. Edward Leonard, Tobias Axelson, David Rossiter, Michael A.B. Watts, Joe Knapp, Dirk Bester, Chris O'Kane, David Bill, Davis Best, Eric Graves. Join our community at patreon.com/universetoday. Kiwi Bacon 99. If a giant alien ship entered our solar system via an FTL type drive, would it displace space and disrupt it, causing a space tsunami? So there's a couple of keywords that you put into your question that I kind of need to sort of hold on to. So you said if a giant alien spaceship entered our solar system with a faster than light drive, in other words, some kind of warp drive, then that defines a bit of like how this system works, which is that it is warping space. And when it completes whatever is its space warp, then the space will bounce back to its normal unwarped version. And so it wouldn't create a space tsunami. Like, I'm sure there's some closeness to the warp bubble that you could get where it would, you know, you're part of space-time. And so having space-time warped means you get warped as well as the space-time. And if the ship passes through you, directly through you, maybe you get warped. But it's not going to cause some kind of ripple that's going to go out there. But, well, I guess it kind of will, because it will cause gravitational waves. You know, one of the theories on how we could potentially detect warp drive spacecraft is by the gravitational waves that they emit. We know that all mass that's moving emits gravitational waves. Like I'm waving right now, and now I'm emitting gravitational waves off my hand, but they're not very big. And so you really need the most violent, massive events in the universe, colliding black holes, to actually get a significant amount of gravitational waves that you could detect. But one theory is that if we saw a warp drive spacecraft fly past, then we might be able to detect the gravitational waves in the wake from that spacecraft. And if the spacecraft explodes, if they have some catastrophic failure of their warp drive, then that should give off a very powerful gravitational wave signature. Then maybe that's the kind of thing that we could detect. And so we may only detect faster than light spacecraft when they are destroyed because of some accident or space war or something like that. Uğur E. What does James Webb orbit? On Google, it says it orbits the sun, but why does it have a circular motion? Right. So James Webb orbits the sun at the Earth-Sun L2 Lagrange point, and so it remains in exactly the same position from the perspective of the Earth. It is on the other side of the Earth from the sun, and it's there because then it can keep the Earth, the sun, and the moon, which are the three main contaminants of infrared radiation, in the same spot in the sky. And it has this great big sun shield that blocks that light, and that allows the telescope to remain very cool. And instead of just sitting at that one L2 Lagrange point, it orbits around it. And so while the Earth is going around the sun, James Webb is going around in this circle around the Lagrange point, but still lined up with the sun and the Earth. York, Fraser, are you familiar with the dark forest theory? What is your opinion on humanity sending signals to outer space? Yeah, I'm very familiar with the dark forest theory. I've read the 3 books. So the first one's called The Three-Body Problem. The second one's called The Dark Forest. The third one's called Death's End. And so the theory about the dark forest is that we live in a scary universe, and the various civilizations that are out there are aware that if they make themselves known to other civilizations, then they may risk someone doing a direct strike on them to wipe them out, because another civilization that is out there is a potential threat. And this, has this plays a role in the books. But people have taken this idea and said, well, is this really an explanation for why we don't see any aliens out there? And it's fun and it's interesting, but I don't find it very plausible. And that's because you can't hide that, humanity has been pumping out electromagnetic radiation into space for 100 years. We've been modifying our atmosphere with chlorofluorocarbons for 75 years, whatever. We have been putting industrial pollutants, sulfur dioxide, into the atmosphere since the Industrial Revolution, hundreds of years. We have been lighting fires around the Earth. Maybe that's detectable, but really, life itself has given us away. So when cyanobacteria took over planet Earth and filled the atmosphere with 21% oxygen, that's very strange. And advanced civilization out there and that happened 500 million years ago. And so, that's 500 million light years away. You could see that event. And so any advanced civilization with a powerful enough telescope, we're planning eventually to build the solar gravitational lens, which will allow us to see a megapixel image of another planetary system with a 1 meter telescope that is positioned using the sun as a lens. We will see planets in all of their glory. And so you can imagine that other vastly more advanced civilizations has done the same. And so they're able to see our cities, our various civilizations at various times in history. So that's the problem, is that you really can't hide. And we're about to develop the technology that will allow us to see other civilizations out there. You've got to expect, if these other civilizations are millions of years older than us, right? Like, what kind of technology do they have available to them that they could try and scan the universe around them? Or they send spacecraft. You send a tiny little self-replicating robot probe to one star system, and then it makes copies of itself, and they go to other star systems, and they make copies of themselves, and they go to other star systems, and then they send messages back home telling home base what they found. And within about, I don't know, a couple of million years, you could have mapped out every single star system in the entire Milky Way, down to the atomic level with your von Neumann probes. And so that's the challenge, is that, well, how do you hide from von Neumann probes? You don't. So that is why I don't think the dark forest is the rational solution to why we find ourselves alone in the universe.
Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call that Q&A Plus. And this week's bonus question, did the universe start from a black hole? And I'll put a link in the show notes. You can click directly over there. All right, those are all the questions that we had in this episode. Thank you, everybody who asks your questions in the YouTube comments, everybody who shows up for the live show. We are still on our live stream hiatus, so we'll be back in about 3 weeks. But until then, I'm going to explain something very unusual that I do. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Braley Griffin, Brian Bodie, Carrot Chuck Hawkins, Commander Baylock, Cy Nelson, David Giltana, David Mast, Evan Pearl, Greg Feely, Hudson Moore, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Marcel Smith, Michael Purcell, Modzo, Nick Borquez, Nick Solari, Paul Rohrbach, Ren Kaidu, Robeck, Sean Sargent, Stephen Fallon Munley, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So one of the benefits that I offer to people who become a patron is you can do a one-time, one-on-one personal interview with me. And for those of you who have never gone through this yet, we meet up on Google Meet. And for about 15 minutes, I have a bunch of questions for you about where you found our content, what you think we do a good job of, how we can make things better, what topics you're interested in. And then, of course, I want to know what you're watching, what you're playing, what books you're reading, and so on. And people are shocked when it's actually me. There's not some kind of, AI that they're expecting. No, it's really me. And we talk at any level. And people wonder, why do you do this? And the reason is twofold. So the first one is that it's genuinely useful to me as a creator to know what my audience wants, what they like, what I'm doing well, what I could do better. I've learned a lot of really valuable lessons about the kinds of content that really resonates with the audience, about how we really specialize in near-term technology. And I'm not that interested in long-term, Dyson spheres at the end of time. I'm more interested in a practical technology that's going to solve a real world problem. And that really resonates with the audience. But the other thing is that creating content on the internet is a rough gig. People are mean. That, you may have 100 comments that are very nice, but there's going to be a couple in there that are really mean, that someone had a bad day or they're just a mean person and they make these comments. And it stings. And I think for a lot of people who create content on the internet, it's really tough to put your work out there day after day after day to a wide general audience. It doesn't really care too much about you, or even kind of enjoys trolling you or whatever. And it is a sort of negative mental state that you get into. But when you talk with a person who genuinely loves your content, they love it so much that they're willing to support the work that you do, then it's this really pleasant experience. And so for those of you who are creators, who I think are very nervous about reaching out and connecting directly with your audience, I've now done 1,000 plus. I've done 1,100 of these interviews. And only a couple of times it's sort of been not a pleasant experience. The vast majority of the time, I really enjoy the conversations that I have. I walk away sort of feeling like humanity's all right. I'm buoyed by this. And so it's good for the heart. It's good for the soul. And so this is why I do it. And remember, we are doing our summer sale right now. That means you get a 57% discount on your first month of our Patreon at any level. And that includes the personal interview with me. So if that's interesting to you, go to patreon.com/universe today and sign up for that 1 month. All right, we'll see you next time.